Nsabimana. I'm a partner. I'm a partner at Stepping CTO. Can you also see my screen?
Yeah, we can see your screen.
Yeah, we can see it.
Okay, perfect. So I'm a partner at Stepping CTO. Stepping CTO is a software consulting agency. It's based in Sydney, but we are opening our first office in Kigali, hopefully before the end of the year. And we work with different companies, mostly startups, to launch their products. And we mainly work with companies that are launching on AWS. And we go in as CTOs and try to get them from idea to product. Most of the companies we work with are generally not technical, with non-technical founders. So we go in as the technical partners. I previously founded Cloudscale, which was also a consulting agency. But now our work on Cloudscale is pretty much merged with Stepping CTO. Cloudscale is based here in Kigali, and we are combining our resources to service our clients. In the past, I did work at Irembo in the capacity as an engineering manager and briefly as director of engineering. I worked with Kato. Uh, I was there for 2 years and a bit, or 2 years and a half rather. Uh, and yeah, now I'm back in the AWS lands with other companies. I have worked with AWS technology for since 2016, 7 years. That's 7 years. Yeah, and I'm a solutions architect certified. So I'm going to take this opportunity to share with you a little bit of my knowledge on this stuff and other learnings I got from it. Yeah, I think that's about it. Feel free to stop me at any time and ask any question. But before I start, I would like uh, to ask you some questions. I will share my screen, another screen, and ask some questions that will allow me to know you a bit more. Uh, can you see my screen? My other
Yes,
screen?
we can see your screen.
So I'm just going to poll a few questions from you. I responded to this poll. This is me, based in Kigali. If you can go to menti.com and use this code, the code above, you are going to start to see the questionnaire where you can start to answer. It's only a couple questions, but it's going to give me an idea of who's in the audience and where they are based. So if you can go ahead and you don't need to log in, you just go to this website, menti.com, use the code, and you'll start to see the questionnaire. Okay, some response coming in. Yeah, good to see some people from Senegal joining our community meetings. Very good. Awesome. I think it's almost everyone who's responded. We're going to move to the next question. Everyone has been able to log in, or not to log in, to go to the website. Okay, I will just go to the next question. Awesome. What is your profession? You can, if you're a student or a graduate, you can also add that. You want to have an idea what you guys do on the day-to-day basis. Yes, very good. Breathing every day. I like it. Mhm. All right, we are going to the next question. Uh, what is your current level of experience with AWS? Again, I want to gather how many people are using AWS every day, or okay. Awesome. Next question we have you used the following technology before? MongoDB, Docker, Heroku. Okay. Uh, do you have an AWS account? Yes. It's good. right? So I think that is all for the for the pulse check. I Okay, let's see some results. You can continue. You can continue for those who haven't finished. So let's just look at the results quickly together. Um, so so we have. Okay, just want to see the easy way to see this. So where are you currently based? Let's see if we can have them as a presentation. Yeah. So very good. We have we have a number of people based in Kigali, as expected. So Kigali, Kicukiro, Ikondo, Gatenga, Tiburon, those are all in Kigali. So very good. Please continue to share with your friends and other colleagues about this community, that this community exists. We want to grow our community base. Really good to see people in Senegal and Liberia. It's amazing. It's amazing that we can have people join us from that far. But all AWS communities are online, so it's we are limitless or boundless. Uh, Profession-wise, we have a lot of people in IT software related stuff. Very thankful for everyone who's still breathing every day. I do that too. Database admin, systems engineer. Uh, so most, if not all, everyone who's on the call today is actually on the tech side of things. Just a reminder, practitioner is not only meant for tech people, even people working with AWS on day to day in finance, in product management, or other things. They can also learn as much as possible about AWS, because if you are building the platform or product based on that, it's suffice to say you probably need to know what you're building on top of. Uh, we have people with a reasonable level of experience. So I have used it before. This could be a one-off or a few times, but at least some people uh, have used something on AWS, so that's good. Three people use it day to day, so that's great. It's really good. And this person who's new, again, don't worry, this is the starting point. It takes time, but we will get there. There are some technology I wanted to know that people are familiar with. Um, so we have people who have used or know of Docker, MongoDB, and Heroku. Uh, these these have been, I would say, Docker, especially Docker, on the serverless side of things in AWS is a fairly foundational technology and used to enable these services to actually exist or work as they are intended to. So definitely Docker is quite important. Heroku, I wanted to know if people know of Heroku. I think Heroku is defunct, if I'm not mistaken. But Heroku is actually quite similar to one of the AWS services we are going to talk about in this workshop, Lightsail. So people who are familiar with Heroku will see the similarity. And MongoDB has an interface that's similar to DynamoDB, which is one of the serverless database. We'll not touch it too much in this workshop, but we are we are going to refer to it. And of the 7 respondents on this one, they all have AWS accounts. Needless to say, you need an AWS account to practice or aid people. To practice as much as possible. This is about practicing. There is no amount of workshop that would give you the level of experience you need by uh, than the one you do yourself, like a number of hours you need to actually put in to have a deep understanding of AWS, either at a, uh, despite whatever path you are taking with your AWS career, you still need a lot of practice time. As Kato said, and just like any other similar certification path, it will probably take you multiple months of preparing, not so much on the practitioner, but also best to spend enough time on practitioner so that other the following levels you won't spend as much time on them as much time on them. So yeah, I think that's it really. Everyone, I think I have some idea of who you are, what you know, and what you do, and where you are. So good. So I think we know each other a little bit. Any questions so far? Okay.
All right.
No, no
Mhm.
question. All right. I think I'll go ahead and start with the presentation. As I said, today we are going to talk about other AWS compute services. Namely, we are going to look at ECS, Lambda, Batch, and Lightsail. In the previous workshops, we did look at EC2, and EC2 is the core compute service provided by AWS, but also these other ones are available for use. Um, the format is again for the purpose of preparing for practitioner certification. It's really important to know what is available and when to use it. What is available in AWS? What does it do, and when to use it? Bear in mind, there's a whole component of how to use it, which is what you do when you are following other stream, like when you start to do solutions, architect, developer, DevOps. That's when you start to really dig deep into the how. Uh, Especially that you at that level maybe you have also started to use it professionally, so you need to understand how to use these services. Uh, these compute services we are going to talk about are reasonably advanced. They are good to know. They are reasonably advanced. However, we will not be touching too much on the practical side. We'll do some prac, but needless to say, some of these things require uh, a lot of other services to work together to actually work. So I will not enter too deep into the how. I'll just do some demo of what they can do. So today I will really focus on the what they are, what they can do for you, and when to use them. Now, what is Docker? So I probably won't spend too much time here because I think 6 of the 7 respondents say that they know something about Docker. But Docker is a software development platform. I would say it's an abstraction layer. It provides an abstraction between the host machine and the application you're trying to run, providing a unified environment for which you build your software for. For example, in the past, uh, many years ago, people used to build software and run it on the host machine directly or on the VM. Uh, People had to learn the Windows API, for example, for Windows back in the days. But people don't do that anymore. They have like what I would call like intermediate layer that the Docker, for example, platform like Docker provides, implements all of that for you. So what you need to do is to focus on building your application in your preferred language, package it as a Docker image, and run it as a Docker container. So some essentially what ends up happening, you can build your application and it can run on any machine. What it means is that you don't need to have multiple builds, one for Windows, one for Ubuntu, one for other Arch, variant of Linux, Apple, and so on. So the Docker platform itself has variants and provide a unified API for that. So that results in a removal of compatibility issues that used to happen before, predictable behavior, less work. So you build once, deploy everywhere, easier to maintain and deploy. So you are dealing with one, let's say, one source code and deployment. You are dealing with one type of deployment API, so Docker deployment API. And today, Docker supports a lot of languages, all of the languages, because Docker provides you a virtualized language, a virtualized environment for an OS like a Linux, a Windows, even an Apple, a Mac environment to exist. Another thing is that Docker allows scaling containers up and down. So in the EC2 workshop, you learned about scaling, horizontal scaling, and Docker allows that to happen and utilizing the same host machine. So Docker introduces this concept of images. So these images are built artifacts of Docker, and they're generally stored in a Docker repository. There's one that's very popular, Docker Hub, which is available on this link. Most popular images exist there. Most basic images exist there, so you can find your Node.js, your Go, your Nginx, your popular database images, and so on. But also there are private repositories. Amazon provides a private repository called ECR, and this is one is, let's say, integrated with some of the services we are going to talk about today. And that's why we started this workshop really with talking about Docker, because it's a foundational technology that enables services like ECS to actually exist. A Docker Hub or Docker repository, I think GitHub provides one, and GitLab as well. Azure, all these other platforms, they have different type of Docker repositories. They work the same way, and this has sort of also enabled cross-platform integration, where you can have you can host your own on premise for whatever reason, and you can deploy in a cloud environment. That also is possible. Now, looking at Docker from a virtualization point of view, it's similar to a virtual machine, but not exactly. It provides the similar idea of virtualization or similar concept of virtualization, but it does share resources with the host, which is not necessarily the case with the virtual machine. And also it uses a lot less resources. If you look at virtual machine here, a virtual machine, when you start one, you actually start an entire OS, so you can run a Windows, a Windows virtual machine, a Ubuntu virtual machine, and another virtual machine or multiple virtual machine on the host machine. But every time you do that, you are essentially booting an entire OS. So you use a lot of resources. Docker on the other side, it has a Docker daemon which implements the Docker API, and your Docker image uses those Docker API to talk to the host machine. So you don't need to to boundary the OS inside your application. So your application is essentially your business logic, and the other libraries it's depending on. That's it. So from a utilization perspective, a single EC2 machine can run more Docker containers running the same application compared to if that was being run in a virtual machine. So I think that's one way to look at it. Any questions so far? Any question on Docker?
I guess we are all on board on the Docker container, so you can continue. Thank you.
Okay, very good. So now we can start to look at Elastic Container Service. So this is a compute service provided by AWS. Uh, it comes in two flavors. There's the original ECS service, is this one we're going to talk about. But after there was another one that was released called Fargate. We'll look at that in the following slide. But essentially, what this does is container orchestration. It does container orchestration for you. Anyone who's familiar with Kubernetes, this is kind of like a precursor of that. And you have your EC2 instances, and it's going to launch your containers on the EC2 instance. You do have to provision and maintain your EC2 instances. So the same way that we saw in the EC2 workshop, that you choose your instance type, you choose the CPU, memory, and this configuration. All that stuff you still need to do it here. What's different is when you are starting stopping your containers, ECS will do that for you. For EC2 instance, you always have to do like your startup script, and you point the startup script to where your application is located and it's going to start it. But here you point to where your Docker image is located, most likely in the ECR, and then ECS will launch that for you. It's integrated with the application load balancer. The same rules apply here, where you can say, I want my CPU utilization to be at this level, and I want to scale if it reaches this level. I want my memory utilization to be at this level and scale under these rules. So the same rules for application load balancer will apply here, and ECS will take care on launching new Docker containers. The difference here is that it's actually going to launch Docker containers. It's not going to launch a new EC2 instance. Not always, right? So you have a higher utilization at this point. So you can have the same application, multiple instances of that application running on the same machine. And when you actually reach maybe that machine utilization is close to 100%, and then a new instance will be created. So that's one of the major differences, that when you scale, you are actually going to scale your Docker containers. You are not going to scale your EC2 instance, and ECS will decide when to launch more EC2 instance. So in this regard, you actually end up having a much higher utilization per instance than what you would do if you were running on EC2 instance alone. Fargate is a much more intelligent service that does exactly what EC2 does, but here you actually specify your CPU requirements and your RAM requirements. So here you entirely focus on your application. So you decide, okay, my application is going to need 1 GB of RAM. It's going to need maybe 2 units of CPU, and that's really what you think about. So you don't need to think the instance type. You don't need to think if it's memory optimized or if it's network optimized. So there's a lot of infrastructure work you you don't need to think about. And in today, these days, this is a far better service to choose, um, especially when you don't have when you have a smaller infrastructure or DevOps team, uh, and they or you don't have a lot of experience with AWS. You can use Fargate, which allows you to think around your application on so memory usage and CPU demand that you want to provide. And ECS, it's still ECS, but the platform is Fargate, or the service is Fargate, but it's still really Elastic Container service. And then it's going to launch them on a on one machine or multiple machines depending on utilization. So this here you can see I try to use something that sort of demonstrate all the other aspects of compute that we have used, the VPC side of things, the load balancer, and it's going into the ECS service that determines how many units of work of work to execute, and that's done transparently to you. And yes, that is serverless. It's serverless in a way that you don't need to think about the server. The server is still there, but you don't need to think about it too much. So we did talk about ECR already, but it's a registry for your images. It provides you a private registry. It's integrated with Amazon ECS, Kubernetes, and other services, even Lambda. Um, Last week, if I recall, you also did learn about deployment. So whatever deployment mechanism you're using, you can deploy your Docker image to the ECR given, of course, the right permissions. Again, as I said, some of these services are fairly advanced and require a reasonable level of understanding of other services like IAM, 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 permission setting, and other for them to work correctly. One of them is ECR. Like if you want to push your Docker image on ECR, you need to have the right level of access. Similarly, your service cannot just pull an ECR image. You have to allow that to happen. So there's a whole lot of things that actually goes into enabling these services to run. But yes, the ECL will provide you your private Docker registry that ECS, Fargate, and Lambda will use, and Batch as well. All services that rely on Docker basically. You definitely can integrate a private a private repository that's outside of AWS, but it's going to make the work a little bit harder. Any questions so far before we go on to serverless?
No questions right up until now, so we can go serverless.
All right. So we did touch on this when we were talking about Fargate is the first full serverless service for, let's say, based on EC2. So that's and serverless essentially is when you don't really have to think about the EC2 itself, the compute side of things, the type, what it's optimized for, its memory, its disk, all those things that normally you need to configure. And you can even go as far as creating the AMI. That's or like you are sort of crafting a lot of things before you get to the point of running your application. So serverless really shifted. It's more like a developer focused uh, um, paradigm where you build your service, you code up your application, and really you deploy it and it runs. There are multiple services in AWS. There are multiple services in AWS that fall into this category, and some of them are not usually obvious that they are serverless, but any service that scales infinitely, so it's on demand, and whatever you need is available, uh, is classified as serverless, and you don't need to you don't think about provisioning and managing the underlying compute. Uh, what you think about is usage. Every time you are only thinking about usage, you are using actually a serverless service. So S3 bucket is one of those services. Um, uh, S- for those that know, S3 bucket is actually a file server. So behind all of that, there's an actual server that's running, and it's running your file system that hosts or your object, a file structure for you. Um, so in the old days, maybe this would be like your FTP server would be your S3. But today in the AWS land, you don't need to think about you don't even think about the protocol it's using. You just access it via HTTP. Uh, really, it's HTTP or your CLI, and it's available for you. So you don't think about how it's fully distributed and it grows as for as much as you need it. It doesn't have any limitation or many limitations. So it falls into the category of fully managed, doesn't and scales infinitely, doesn't require involvement on managing the compute behind it. Similarly, there's Amazon DynamoDB. This is one of the popular services that are serverless. Again, as I said before, it's similar to MongoDB from an interface perspective. So the way your application is interacting with it, it's similar to MongoDB. Not exactly the same, but very, very similar. So it uses like a JSON object for data transfer. Not exactly JSON. Some of them is binary encoded, but it's similar, very, very similar. It has a very simple API similar to MongoDB on accessing the documents of collections and so on. So for anyone who has used MongoDB, they'll be very, very, very familiar with. They would find DynamoDB very familiar. As I also said, as we just saw, Fargate is one of those services where you don't need to think about the EC2 running behind it or how many jobs to run on a single EC2. It just scales that for you until it hits your rules, which is maybe your CPU utilization rules or your memory rules, and then scales up and down as needed. And the pioneer of serverless is really the Lambda function. That was the first concept that AWS used and presented as a full serverless compute service. Yeah. So if we were to look at Lambda vis-a-vis EC2, the Lambda is using the concept of virtual functions instead of a virtual machine. Your EC2 is running, it's a virtual machine available for you, but your Lambda is a virtual function. What this means is that you don't need to think about all the other aspect of the OS that is needed for your business logic to be executed. So you present your business logic as a function, and the Lambda environment will execute that for you. In a virtual machine, as I mentioned before, sometimes you actually need to create your own AMI depending on what you need to do. So you are essentially packaging a lot of other software and libraries that you need for your business logic to be run inside your virtual machine. There's a limit of RAM and CPU on EC2 instance, when you choose an EC2 instance, it has those hard limits on the RAM you can have access to, and the CPU you can use. Lambda, on the other hand, it doesn't actually have it doesn't have a limit, but you can choose to increase that on demand. On the EC2 is slightly different because it requires an actual deployment of the application, the creation of the instance altogether. So you don't have that ability to choose on demand. EC2 by nature they run continuously. Once you launch it, it's running forever. But Lambda are run on demand, event driven. Either they are run when an HTTP request comes in. So when you're using Lambda, maybe as a backend for your application, it's going to run when that event actually happens. Whereas an EC2 instance running a web server, the web server is continuously running, waiting, and listening to receive the request. When you are scaling EC2, it actually means adding or removing instances either through a scaling group or doing it yourself manually. But ideally, you should be doing that through a scaling group, auto scaling group, and it's going to follow the rules you set. But it's also limited on how much foresight you have. So if you say I'm going to only need 2 instances and you configure that, then it can only scale up to 2. If tomorrow, after tomorrow, you need 3 or 4 or 5, you actually need to intervene manually. For Lambda, it's not like that. When your service becomes very popular, it's going to scale up to the account limit. There are some other configurations you can do there, but generally it can scale up to the account limit. So as we can see, one is fairly pretty much on-demand virtual function. So you focus on the functionality and run it when it's needed. Whereas EC2, you focus on the entire machine, its resources, and it's always running. The benefit of Lambda is a pricing model. You pay per request, and you also pay for compute time. So how many requests have you received, and how long did this request run the Lambda for? So in the free tier, you receive 1 million requests per month and 400,000 gigabyte seconds of compute time. It's calculated in gigabyte seconds because a Lambda you configure the RAM. As you can say, I need 1 GB of RAM and the number of seconds that you will run it. So you get 400k GB seconds. GB 400k GB. I think I calculate this. If you're using 128 megabytes of RAM, 400,000 GB seconds for 128 megabytes of RAM is actually 37 days. 37 days of continuous execution of your Lambda. So if you take your Lambda as a function and you don't put too much stuff in it, and you can run it very in a short period of time, you can conceptually you can run a lot of your Lambdas for free in AWS. But that's conceptually. When your service becomes very popular, which is what you usually want, you start to pay, but not as much as you would if you were running an EC2 instance, for which you start to get billed on the moment you launch it, unless you're using the free tier version. So Lambda is integrated with a lot of AWS services. It's event driven. So the function will get invoked by AWS when it's needed, either through a HTTP call. We'll look at that later, but it can also support other type of events. It can be invoked maybe when something happens in your S3 bucket. on your DynamoDB, on your you can have a virtual scheduler that's going to run it. It can be invoked by literally many other things. It has many sources of invocation. Lambda supports many programming languages and runtimes. So the most popular languages like Python, Node.js, Java, Go, all those are supported. You can monitor it in CloudWatch, just like any other compute or any other services, really. You have access to CloudWatch. You can get up to 10 GB of RAM and 15, I think there's also a 15 minutes execution time. Ideally, you should use Lambda for things that don't run too long, because the moment you start to run your Lambda for too long, it will cost you more than if you actually use an EC2 instance. So that's where when you start to get into the deep how to, then you start to assess, is this a Lambda type of application, or is this an EC2 type of application? So there's a limit, but most application like web application where you are sending a request, getting a response, those type of things are usually suitable for Lambda. But things like archiving, running, data archiving, data analytics. Those are the type of things that can run for a long time, for many hours. It's not suitable for Lambda. Some of them, there's a tendency to do that. Sometimes you see, oh, okay, I can run for 15 minutes. I have 10 GB of RAM, and you jump on AWS Lambda, but it may start to cost you more. So you would need to make that assessment to see if it's still making sense to use Lambda when you have a heavy application that needs to run for a reasonable amount of time. Another thing here is that one of the nodes or the tuning points for Lambda is RAM. So you can increase your RAM. So what happens when you increase your RAM is that the CPU is also improved and your network. So sometimes you can run an application that only requires 128 megabytes. Like it's a light application, but it's doing a lot of I/O calls. So it's calling a lot of things outside of Lambda. So it's maybe making database connections. It's sending data to DynamoDB or pulling data from S3, and you start to see your application is not actually as performant. Sometimes you increase the RAM, maybe to 512 MB or 1 GB, and your bandwidth, your network performance increases as well. Why? Because all these things actually use RAM behind the scene. Any connection is held into RAM. Any CPU action is actually putting data in RAM as cache. So all these things, you only tune one point, RAM. Increase your RAM if you want a better performance, or reduce it a bit if you don't need a big performance. The runtime supports on language and runtime. So Node.js, you can run your Node.js application. So you can run your Express web server there. You can run your Python. It can be Python scripts. It can be Python. It supports framework as well. You can run your Fast API application. Java, there's a good support for Java, Java 8, Java 11. Your C# .NET Core only, and Shell, I think. The support for Golang, for Ruby. Recently, AWS released a custom runtime API, which is supported by the community. So any fancy language or runtime that people need to support, the community can build like a Lambda API to support it, or integrate with the Lambda API to be able to support it. And this has happened with Rust. The Rust support in Lambda was built by the community, not by the AWS team. Lambda can also run Docker images. It can run Docker images, but your Docker image, your base of of your image has to be a Lambda runtime API. It has to be implementing the Lambda runtime API. So for example, if you have like a Python application that runs in Docker, you cannot just do from from Python version. You have to do from Lambda Python, and those base images are provided by Amazon. But generally speaking, when you want to containerize your application, it means that you need to go to something like ECS and Fargate, because it doesn't have it's supported, but it's not going to always provide all the support you need. Like your Lambda Python version may be limited compared to your open Lambda based image. So this is an example of where a serverless implementation of Lambda can be used. So you may have a service that you are creating a lot of images, let's say maybe Snapchat or Instagram, and all the images are stored in S3 buckets. But when you are running your application, you want to preview a smaller version of that image so that your application is performant, doesn't cause too much constraint on the network. So every time an image is created added in S3, you run a service that's going to make a thumbnail, and this is a thumbnail. Thumbnail maybe the application you would pull and show while maybe someone is just browsing. And when they actually click on the big image for that to load, then it loads the S3, the big one, the original image. So the paradigm of serverless really starts to shift how you think about building the application. In the past, other full server application, you would have like a bunch of jobs running within the same application. Most frameworks used to have the concept of background jobs. So you would say, I upload an image. If the image is uploaded successfully, I want to also have it queued in a job so that I can create a thumbnail for it. But things like Lambda introduced this way of thinking about your application where you can just upload your image and then send an event from S3 bucket that notifies the Lambda to create a thumbnail for that same image. So this is one of the examples of using Lambda in a serverless manner. There's another thing here where you can achieve the same thing you normally would achieve with a cron job. Or for those who have used Linux, you know how you can configure your cron job to do different things, either to run a script, maybe to do a backup, yeah, all kinds of stuff. So Linux has this facility built into it. But in AWS, you can also do use Event Bridge or CloudWatch event, as it's called these days, to configure an event that will trigger a Lambda to do something for you. It can be, again, it can be to do anything. It can be an archiving job, another notification, anything, like any function you can run in Lambda, and it's going to be triggered with a resolution of 1 minute up to however from expression support, which I think it's I don't know exactly, but the upper limit is very far in the future. So yes, you can trigger every day, every week, every year, and you have this serverless facility. It's a one-off configuration, and you configure the Lambda that's going to receive the event. So this is another example of how your serverless Lambda implementation could be used. Okay, so there is a pricing. So there's pricing details here. Actually, Maybe let's go to one of these things. Let me just open it. I found it. I found this pricing page has some good example that puts a lot of things in perspective. I'll share this. So this is the Lambda pricing. Lambda pricing exchange. Let's go to Virginia. So for example, let's use this as a mobile application backend. And here the example we are going to look at, you are building a food ordering app. You have customers who can order for those in Rwanda, maybe this is like Vuba Vuba. So you can order food. And essentially, let's assume there's 3 million requests per month. This is a lot of this is a lot of requests for a small application, of course. And let's say the average request lasts 120 milliseconds. But also no, in reality, most applications, even to achieve like one, like let's say viewing a menu, that's multiple requests. That can result in multiple requests. Placing an order, that can result in multiple requests. So yes, it's a million or 3 million, but it can add up very quickly. But 1 million free request per month is fairly generous, and it's configured with this memory, like let's say 1.5 GB. So if we follow the formula, so 120 milliseconds for 3 million requests. So in the month, this is the total compute time. And then if we are using now the GB seconds, we take the actual configured RAM in GB. So we divide 1024 MB, and we have these many GB seconds used per month. So if we do like total compute minus free tier, so we have total compute minus free tier, we have 140,000 GB seconds to pay for, and that results to be around $2.33. So if you're a startup, most of my clients are startups. This is the kind of money that a startup is willing to pay. Now, if you had the same EC2 instance that has this much memory configured, like 1.5 GB is fairly high. Normally you get like I think the free tier is below 1 GB. Most free tier is below 1 GB. So for the same level of performance, you would be paying a lot more than $2. For the number, another charges is the monthly request charges. So we have 3 million requests. We are paying 20 requests per 1 million, 20 cents per 1 million requests above free tier. And free tier is 1 million requests. So we end up paying 40 cents. So the total cost is around $2.73 per month. And with my clients, this is what we usually do. We start with AWS. We know in the first month, 2, 3, or even 6, in some cases, a year or multiple years, they don't have many requests. They are still testing the market and getting people to start to use their service. And we can run multiple months using the free tier. Also, very good for development. We can do a lot of dev without worrying about incurring too much cost. So this is one thing I wanted to show you to put things in perspective, and also show you that Lambda, in as much as it's short-lived type of functions, it changes the way you think about building applications, especially like web applications. It's still used in large mobile application as a backend, but it can also do a whole bunch of other things like data collection, machine learning, some machine learning. So yeah, people use it for all kinds of stuff, and it's a good way to enter the cloud for startups and small companies without having to incur too much costs in the beginning. So that's what I wanted to share there. Yep. Okay. So yeah, this is similar type of analysis, but with a much here. Uh, Feel free to go back to that website to see more example on how pricing is calculated. I'm sharing or not? Share this. Please stop me if you want. I can see a question. Okay. I'm not looking at the chat, so I'll not respond immediately, but in your experience, are there use cases that are more suitable for one image repository service over the other container and one container orchestration service over the other, considering aspects such as ease of integration with other services, cost, and most importantly, security? I would say for AWS, you should use ECR. ECR is going to fall into the same security model you are using. It's going to follow the same principle. People who have access to it are the same people you are going to allow to have access to it. So from a security perspective, you should definitely use ECR. Uh, the integration side of things, most of these ECR do implement Docker API, so they behave exactly the same from from a Docker perspective. So pushing images, pulling images is pretty much the same. It's pretty much the same. It's fairly unified. So I don't think there's many integration problems. I would say it's more about security and unifying your way of operating. So you can think about it from like a pipeline perspective. Your engineers, your team will be very familiar with your AWS. So it's better to keep all that stuff sort of unified. You don't need to add extra things to think about, configure maybe slightly differently, access differently. So the more you integrate with external ECR, container registry providers, the more attack surface you are probably creating on your service. It is possible, and really it's a choice that comes down to what the team is most familiar with. For people who are starting from scratch, definitely use ECR. No, there's no special cases. Use the same API. There's no special cases around a container registry. They use the same Docker API. In fact, I think Docker popularized this, but there's something called OCI. OCI is Open Container Interface. OCI is really what everyone is implementing, and Docker is one of those provider of or implementer of OCI. But these days there are other implementer. I think there's a fair few that I haven't used at all, but in the open, what is it called? The Linux Foundation, there's a fair few there. In the Kubernetes space, there's a fair few there who are implementing this OCI. So look up OCI. It provides both the runtime, but also the interface for storage, packaging, decoding, all that stuff. So it's the same. It's really open. Everyone is using it. It's just Docker is the most popular by a very large margin. So that's why companies like GitHub, when they implement a container registry, it doesn't look actually any different from ECR. From a usage perspective, you pull the image, you push the image, you use it, no problem. So they use the same underlying standards. So, the hands-on. So as I said, I did prepare a hands-on for Lambda simply because uh, it's the one that I think is going to sort of to really enhance that change of paradigm, thinking about serverless for those who are familiar with other web applications, for example, or other uh, jobs you normally run on EC2s. But also another reason is that other services requires deep integration with things like ECS. You need your autoscalers, you need your load balancer, you need your IAM, extensive IAM permission, your ECR integration. So I think like ECS demo or Fargate demo is actually a bit advanced, and I would encourage everyone to focus on knowing the what does it do for me, when should I use it, because that's what's going to come in the test. And as you build your experience, then with and potentially other workshops we run will be more focused on things like solutions architect or maybe the developer part or DevOps, where we are going to go deep into the how and where we can have like more practical and more practical or demo based sessions. Uh, yeah, I hope what I'm saying is makes sense, Cynthia. Yeah, so focusing on the practitioner side, we are going to really look on the what and the when. I did prepare a demo, so I'll jump to it. I'll see if I can find it. And if the demo doesn't work, I apologize ahead of time because demos just tend not to work. I have my account open somewhere.
Yes, there's no worries, Olivier. If it doesn't work, we won't be putting the blame on you. We'll be putting it on AWS directly, since it's running the servers on its own and we cannot see that. So something we cannot see, something we cannot put the blame on ourselves. Thank you.
Yeah.
Yes, as you maybe are searching for the demo, as I would like to remind everyone that these sessions are currently ongoing and we have them on every Saturday. So if you are free and your calendar doesn't have any clouded clouded schedules, please feel free to join us. And we normally start at 11 and we go through sessions like these and after have like a pop-up quiz by the grace of Kahoot. So, and we also have our WhatsApp group that we normally gather on. So I'm going to share quickly a link for the WhatsApp group for whoever who hasn't joined us lately, so that you can be part of the community and also get to know more about the upcoming sessions. Olivier, kindly let me know when the lab or the hands-on environment is ready. Thank you.
All right. Yeah, thanks. I think I'm ready. Uh, I I just want to go to the Lambda side of things here. I did create this, but it is something that we have to do. Let's do this. Right. So there's this thing when you go to the Lambda dashboard and begin, you can actually see a little bit more about how Lambda works. The AWS has a nice little demo. These are the runtime supported .NET, Go, Java, Node.js, Python, different version of Python and different version of Java, and the custom runtime here. This is using the Rust custom runtime, but the community can also implement other custom runtime for this. Um, Now, so this is like a very simple function, very simple function that receives an event, prints it, and returns hello from Lambda. Uh, Lambda has a very specific signature, and that's how it knows the entry point in your code. For example, the default uh, signature is called Lambda handler. You go, uh, there's this thing. So each language has a way that it notifies Lambda that this is the entry point. .NET, I don't know .NET. So these like handle request thing running here is what like these are configuration. You have to use it, and if you change it, there's a configuration. You tell Lambda this is the entry point. Um, but normally the like in Python, the Lambda you use something called the Lambda handler by default, and it receives two objects, an event and the context. And if you're passing data to your function, it's going to come through the event, and you can use the context information to do other things. Maybe uh, you know maybe other things like the context is a big thing that changes over time, but you can look at the context API to see what you have in there and what you can do with it. But normally you receive your data through events. Here you can run it, and yeah, this is executed. This is totally executed. Uh, in the demo, we'll see a bit more, have more context on when it's run. But what I wanted to show on this page is mainly here. So Lambda uh, is essentially like you think about your application in function. So instead of having one huge application that does everything, you can think, okay, I need to have my image handler as a function. And so you implement it in isolation and you have it, and it's going to receive your image event. I need to have my data analytics as a function. So you can implement simple, very basic application available in isolation. Uh, you can also do things like where you include everything, like web application. I've seen when it's where it's done, or you can put your entire web app, like an Express app. A few things you need to change for it to be compatible with Lambda, but yeah, that also can be run. But the whole idea is to have very simple function isolated from each other that can run individually. So this demo here shows you like the previous function where it's receiving things from different sources. It's receiving events basically either from a mobile app. You may be tracking your app is doing things and sending to the Lambda, or streaming some analytics, or you're tracking who's viewing your web page, how long they're doing that for. Like if you have like your custom analytics, what Google Analytics does for most web applications, basically sending events in the background. Or you can do that like image to S3 and then processing. And that goes to your Lambda. What's interesting about this demo is that if you have multiple events, it's going to start to scale. So you can see it's creating this little code in a box. So those are execution units for you. And it does that depending on how much demand your application has. So you have multiple images, then it scales for as many as needed, right? Your your app is being used and it scales. So that's like the scaling part, seamlessly scaling and responding to events, getting more units of work for you. Uh, Here, cost-wise, this little demo also shows you what we're looking at before. Like you have your 1 million requests for free, and then it starts to charge us afterwards. Like we can, like let's blast it. We're going crazy with Snapchat here, and boom, we start to pay. Uh, or we are doing multiple things with our app, so we actually start to pay, but we started to pay from from 1 million. Like if scroll back, and it's still free until it hits 1 million. So this is like a nice little visual demo that AWS was trying to put together, and so on. So I wanted to show this before we go to the actual hands-on on board. Now let's go to the function I created. I created a very simple application, and you can create application using things like templates. We are going to try to recreate it, and essentially I used something that took something that was a template, but what I wanted to show from a high level concept is how you can use your Lambda to run something that looks like a REST API. So I added an API gateway, and I'm going to invoke the API gateway, and it's going to call the application, the Lambda function, and return the data for me. You can do complicated stuff, but what I took as a demo, I left everything there so that you guys can see. This one was intended to have something else like a DynamoDB table, but the whole configuration of Dynamo, I didn't get to that, and it's also probably beyond the scope of like understanding the compute. And essentially what we do here, I'm sending a payload to event, and I'm passing that into something called body. I have like it's a JSON object which has something called inside body, and I'm returning that. Normally, you can do things with this. You can implement like a post. You can implement like a post endpoint, and put get and delete. I also have to say that frameworks like uh, Express, Fast API, and other like REST API framework do provide some nice facilities where you actually write your code the same way you would normally write it in a server-based application. So you don't need to do like these. I think this is like a custom way of doing. Oh, I want to do a post request. I want to do a delete, a get, a put. There are frameworks that actually support this out of the box, and they are light enough that they don't actually add a lot of like memory usage on the application. So, but this one is sort of custom made. Because I've done this, I tested it, it's running. So I'm sending like a test object here, but it's still running. I'm just checking it's still running. I have an actual endpoint. So when you configure this on the API gateway, you get your endpoint, and you can call this endpoint. So what I have done here, I'm going to share my whole screen. Share the whole screen. Entire screen. You can see my terminal, can you? You can see my terminal?
Yes, we can see it.
Yeah.
Thank you.
So I have the same endpoint here. So I can actually use something like help, and I can send it some data, test data here. I think that's sufficient. You can see that it's the same endpoint. Let's jump back to this endpoint. It's the same endpoint here. I'm calling, and it's going. Oh, let me just remove these logs. And I get a response. So because I configured that to give me back the data I send, this Lambda, you can see the code here. I said, I just returned the payload that I sent back is what I'm getting. What I send as the data is what I'm getting back as the payload. So that's what the API gateway is doing for me. Let me just see here. You can look to monitor to see. This is will be invoked. You can see that we just had a second invocation. This is the UTC time. It's 12. Yeah. Okay. So any more any more calls will actually register here. Mm, Wait, is this actually going? Taking time. So okay. So you can see now we have another call right here. So yes, invocation is registering. Mhm. Okay. So we have two invocations right at this time. Yeah. Again, these are CloudWatch metrics. So your Lambda environment is fully integrated with your CloudWatch. So you can see what's happening with your Lambda straight away. Um, you also have access to your logs. So you can see how much memory you are using, what's being logged, and this takes you straight to the CloudWatch. If you click to the log group, let's see what it's going to show us. Ah, it's not going in the- Oh, I'm not. Should be logging something here. Oh, okay. Okay, so it's now we can see that it's logging. So if we go back to CloudWatch, normally it appends your logs next to each other, but sometimes you don't see that straight away. So you go back here. See if I can- um, let's see. All right. Okay, configure the function. What is this log? I was expecting to see the same log as what I saw when I ran test. When I ran test, yeah, I was expecting to see this printed out in Blackboard. Mysteries. Anyway, this is generally the idea. Like you have access to a lot of things in your Lambda environment, and it can also be used in interesting way, like an API, basically an API implementation. Let's This word is not. Okay. So now we have the data that we're sending, we just print it out. So you can have access to your logs. Very useful for debugging when you have issues. So all your information will be available in CloudWatch. Yeah. Now, so at least now I know I have a working version of this application. So I'm going to create another one exactly like this one, just to show you the steps I took to get to this working version and how I attach different resources. So you go to like in your dashboard function, you can create function from here or from there. This is overall account dashboard. And do note that we are in a specific region. You can change the region depending on where your usage is going to be, but North Virginia is normally the cheapest region. So I usually use it for this type of things for demo, just if I ever forget to shut it down. But if some clients are based in Europe or in South Africa or in Kenya, like you need to choose the region that's close to your usage, uh, because there's other things like network latency still apply. So you can choose to create from scratch. So you build from scratch. I should also add multiple deployment mechanisms do support deploying directly to Lambda. I wasn't in the last session about deployment, but deployment itself is a big thing that you will need to learn and understand. Supports like your different type of to ECR, where you deploy directly to Lambda, uh, or you can deploy directly into an EC2 if you are running like a binary or another package application. So deployment itself, you can look at it separately and choose the right way you want to do it. I think AWS provides a service called Code Deploy that you can use, connect to your repository, and you can define the rules or your script, and then it's going to do the deployment for you. But many other providers do have those facilities like GitHub Actions, GitLab pipelines, Bitbucket pipelines, all those things you can use already, which are already within your repository, and you can deploy to AWS. But for the purpose of this demo, we will use a blueprint. A blueprint is a function that's already built, and you can create a microservice. The one we had is also a microservice. You can do like the HTTP. Maybe that's what we should do. Let's just do this. I wonder what this looks like. Yeah, so you can choose multiple type of things. So there's a whole bunch with Node.js. Yeah, demo, let's call it that way. It's going to be Node.js. We want it to have Lambda permissions. It's going to create them for us. Yeah. So I think it's self-contained. We don't need to add anything else. So this is like public. That's why they're giving us a warning. Yeah, so that remind me to delete this please afterwards. Yeah, and yeah, let me see it. By the way, there's some renovation near my office, so please bear with me. There's a lot of noise around. All right, so we have our demo app. This one here we have the HTML. So this is like the web page we want to display, and we have it accessible on this link. So we have created the Lambda, and we can have like a function URL for that. And if we put this here, it's going to load the page. Hello from Lambda, from AWS Lambda. So it's loading the page for us. And if we look at this index HTML, it's exactly what it's doing. Hello from AWS Lambda, the blueprint function we created rendered this page. So if you think about it, like you can create a very basic page using this, but as I also showed, you can create an actual like API endpoint by utilizing the API gateway. Yeah, by the way, if you look at the API gateway in the next section, we will just touch on it. So you can see that despite uh, this shift of paradigm, serverless is a fully capable way of building application, web apps, API applications, scripts, jobs, and anything really you can think of, you can build. And the advantage here again is it's on demand. It's you pay per usage, not per provision. EC2 you pay per provision. The provision, if you use it for a month, you pay for a whole month, even if you only had like a couple of requests going through it. But for Lambda, you actually have you only pay per usage. So if it's never used because you don't have customers or users yet, then you don't pay. So this is usually a preferred way of doing things when you are starting up. Anyway, we'll jump back on the on the presentation. I encourage everyone to again to continue to learn. Go to your AWS account, practice. That's the only way you can be good at this stuff. Needless to say, AWS changes a lot. There's a lot of services, and they get updated all the time. So the best way to stay up to date is to literally use it as often as you can. Your personal project, if you're not using it at work, you can host your personal projects there and have that familiarity with it. And also practice for these certificates. Either practitioner, and afterwards you choose a particular task, you practice for that, just to keep your knowledge up to date. I'll take a quick look if you have any question here. No question in the chat. I'll go to the next section. Any question? Any questions so far?
I think we are in a questionless zone right now. So yeah, feel free to continue the session. Thank you.
Okay, perfect. All right, so the API gateway, I did show that one of the things I did was actually use an API gateway that I can access using the standard REST in the REST format using the HTTP protocol. So you can put your Lambda functions behind the API gateway, and you can have your mobile app accessing this, and you will be able to build your app and not worry about building a backend application. Other than you will build the backend application, but you will not manage it using a web server like a standard web server. And you can go as far as using a serverless database. Amazon DynamoDB is one of them. It's a very good one to start with when you're starting up because it supports it's a document based, it's a non-SQL and document based. So interacting with it from a REST API perspective, it's fairly natural. You have the JSON object coming in as a request or being retrieved as the response bodies, and DynamoDB will store them in that format or a similar format to that. So it's a good way of having a fully serverless application. Lambda, DynamoDB, and Amazon API Gateway. Again, it can scale infinitely. The API Gateway, it can provide other things like security, user authentication, throttling, monitoring. All these things it's going to provide them for you for free. Normally, in other apps, you need to add other either software application or in some cases even hardware appliance in front of your apps to be able to do things like security, throttling, monitoring. But yeah, you get this for it's available as one of the AWS service. Aurora. Aurora is a SQL compatible database that is also serverless. I think some people have started to use it. I don't know if it's full mainstream today. I haven't used it a lot, but for those that are using like SQL based database like Postgres, MySQL, Aurora is there. It can be used. And not only that, you still have access to RDS services like Postgres, MySQL, and so on. Lambda is well integrated with those, but not that because those are not serverless application. Those databases they behave the way you would expect them to behave. They are connection based, so every time you create a connection, it takes time to connect and more time compared to a serverless offering like DynamoDB. It's going to use a lot more memory, and managing those connections is very different because you're in a serverless environment. Maybe when you exit, you need to close the connection or cache it in the context. So it can be a little bit more complicated to use a traditional database with Lambda. That's why it's much more preferable to use something like a DynamoDB and Aurora databases for your serverless application. So now on API Gateway, it supports REST and also WebSocket. So you can do streaming in both direction, and you can use standard REST API. Yeah. Batch. Batch. So batch, it's kind of like the way I see batch is more like your EC2 or your EC2 and cron combined and the event bridge. So batch really you define your start and your end time. Your start it can be an event or it can be time based. But your batch job normally you want to run like a really long run jobs, like archiving, like backups, data transformation. These things that may take multiple hours. So things to do with like a lot of data movement usually you use your batch. Batch runs your Docker images as containers, and essentially you will define your job as a Docker image, and you connect that to a batch, and the batch will run it on an EC2 instance or a spot instance. Another thing here that is useful is compared to like simply running your EC2 instance, the batch will only run on demand. It's going to run on demand, and the demand will be defined by maybe the start time or some other events that will happen. So you will not always have your ECT continuously running. And if these are stateless jobs, like jobs that can be stopped at any time and repeated multiple times without causing any problem, you can also configure that to spot instances to reduce your costs. I see that as more yes, you just submit your job. You just submit your job and it's going to deal with the rest. I see this as like in between your ECS and your target. Your ECS and your target, or even your Lambda in your target. Like it's gonna run for a long time. You don't need to worry about the EC2 instances too much. And you just define your job as this with you define your job, you specify your compute and your memory, just like target, and it runs on trigger. The difference between this and target is that target actually, in some cases, your target will run continuously. So you can have a service that runs a large application. It can scale on demand, but always runs a minimum of like one instance. So in that situation, you actually have one instance running continuously. And then if you have a lot of work, you can scale up. You can scale down to zero, but when you scale down to zero, you know it takes a long time to start. So normally on Target or ECS, you actually always have one job running, at least one job running, just so that your service doesn't feel slow or it has kind of like a very slow start. On the backdrop, on differently to the backdrop will run on demand. Let's say 11 o'clock at night, I want something to happen. And that's when your EC2 instances will be spun up. So basically a backdrop, things that only need to happen at a specific time of the day or of the month, or under specific condition, like a specific event happens. Like maybe your database hits 80% usage. I don't know. Yes, example, archiving S3 to Glacier. Glacier is a cold storage. It's S3, but specifically for archiving. For example, you may want if an image is more than, or an object, doesn't have to be an object, it could be a video, it's more than 2 years old, you may want to store that at Glacier. So you may run a backdrop that comes, checks everything that's older than a year or two, and it puts them into Glacier. And that's going to cost you a lot less because it's in a low-cost storage called the Glacier. Data pipelines, ETLs. So you may receive a lot of data, like a database, a transactional database like Postgres, receiving a whole bunch of data. But you also have your data warehouse, like ClickHouse, which is it's a different type of database that stores data differently, and it can store a lot of related data or a lot of data, like things you would put in multiple tables in Postgres, you may be able to combine them. Maybe they are related somehow, and have them available in ClickHouse in under one table. But also the storage is slightly different. One is row based, another is column. So you can run a pipeline that literally comes and reads your entire database and puts that into another type of database suitable for things like analytics. You can imagine this may run for a very long time, or or maybe at specific time of the day. So suitable for something like a backdrop. So those are the two examples I could come up with, but there's many other. I think in your business application you may find many other use cases. Yeah. So batch versus Lambda. Lambda has a time limit. Batch doesn't have a time limit. You can run for as long as you want, or as long as your as long as the job is running. Lambda has specific language it supports and ways it supports them. So the runtime, you may not be able to do Lambda like Node.js version 12, for example. You can't do that anymore. But for batch, anything that goes into a Docker image will be run. That's it. Memory, like disk space, Lambda has some temporary disk space you can use, but actually I don't think it's recommended to use that. You can use it, but you can use that through a file system. But because that IO is a bit slow, it's also going to give you like a time penalty. It's going to cost you more when you start to do those things like file system, download the file, store it on the locals, on the Lambda storage, and process it. That's expensive. Sometimes it's better to use like a streaming, like read a file. Maybe you're reading an S3, stream the S3 object into Lambda, but use it on the fly. On batch, you can do that type of stuff because you also have an option of attaching EBSs, and that will give you more memory. Like what I was saying, you may be trying to do like copy data from one database type into another database type. Maybe you actually want to do like a database dump so that you can free up the database connections. Like you don't want to run like a 6 hours job in a database that other people are using. So you may do something like that. That's literally going to require you to do crazy things like data dump on the EC2 instance running the batch job and then do your processing from there. And also this one is batch is relying on the EC2. Lambda does things, and sometimes it does. As far as we know today, it still relies on EC2. But who knows? Tomorrow they may find another way of using that runtime, the Lambda runtime in another type of environment, like Firecracker, for example. I think that's what they use for Lambda. Right, Lightsail. So Lightsail is an AWS service. I've never actually used this one. The reason why I asked you, has anyone used Heroku before? I think Lightsail is very similar to Heroku in a way. It gives kind of the same feel. I'll just jump on Lightsail and show it to you guys too. Maybe those who have used Heroku will find it familiar. Okay. So again, you search, you just search it. Just like you access any other service, just to search it, go to it. And this is how it looks. As you can see, this actually looks very different to other AWS service. It's separate. It's on a separate subdomain. Usually, other services are within the same domain as the same domain. And yeah, this is how it looks. I don't know when this was created. If this was created before EC2 or after, or at some stage, but this was really kind of like a competitor to Heroku. So when you do create, this is what you see. Does this look familiar to anyone who has used Heroku? Like you can choose like Linux, you can run things like WordPress, a LAMP application, Node.js, a Mean application. So you can see like it's providing that vibe where you are now thinking more at the level of the application, not the level. So sorry, at the level of the framework you are using, not the level of the business logic. And I think that's where Heroku was at. It was like your Ruby on Rails, your WordPress, your Joomla, your Magento, your main application. Like there's this way of thinking about like a framework that runs the application. So if we do like this, and you can you can choose, or even digital ocean. Digital ocean. You can see like your predictable pricing here. You can say for $5 you get 1 GB of RAM, virtual CPU. This is the disk space of SSD and hard drive, 2 TB. So really, this is kind of like goes back to that way of thinking about application, but it's not. I don't think this is very popular anymore. Lightsail is not very popular. You may start with it, but at the same time, it's also slightly different to other AWS services that I feel that maybe the right way to do it is to go straight into AWS services and actually try to get a good understanding of it. But if you are migrating to AWS and you have like your WordPress app, your main application, you can just launch it this way and have this run straight away before you start to go and into the serverless mindset, changing way of thinking about your app, and so on. So we have, okay, it's now deployed in London. Also, the zones looks different. Like, oh, yeah. Uh, oh, let's wait maybe a little bit. It's probably trying to start up this instance. Yeah, it's still starting up. Let's wait a bit. But in the meantime, I'll just share this. So Lightsail virtual servers, it gives you your server, your EC2, your storage, your database, and networking. It has a low pricing and it's predictable. So it's a fixed cost. Like I want to run this and I only want to pay $5. Um, so it's simpler. You don't need to know your load balancing, your auto scaling group, your IAM permission between different services, your all kinds of stuff from the things we have learned, like EC2, RDS, ELB, RAT 53, and the others. You can start with it, maybe with if you have cloud, limited cloud experience. But also, I think like if you have an app you just want to host in AWS, like Heroku just shut down recently. So you may say, I have a Heroku app, I just want to chuck it into AWS, Amazon Lightsail. That's the way to go. Yeah, and it's like use case based. So you have your framework combination of Mongo Minis, Mongo Express, Angular, and Node, right? Yeah, or Node.js for LAMP. I don't know what that stands for. All these website framework and so on. So, it's highly available, so you can deploy in multiple zones, but not auto scaling. Let's see if it's available now. So little known application framework, little known like offering from AWS, but useful somehow. So this is the application I launched, the workplace application. That's the IP address. That's the IP. Let me see if I can. So I have access to the terminal. I can see like what's there and can do the stuff you normally do on your WordPress app. It does have a public IP, and that's the public IP. Let me see if I copy it. Maybe it's going to show me something. Yeah, it's showing something. So I put the public IP here. Yeah, so this is my blog, my first ever blog. Um, so yeah, that's Lightsail for you. It has some use case, simple to use. Uh, no need to have deep understanding, and more specifically, if you're migrating traditional framework-based application, it's quite a good alternative. Uh, Oh, that's the demo. That's the hands-on. What else? Summary. Docker container technology to run applications. Most of you are familiar with Docker, so you can see that it's a key enabler for serverless on AWS, be it Fargate, be it Batch, all those services rely on Docker to run.
Hi, Olivier.
Yep.
We can see your screen. I guess you're okay. Yeah, you can see it now.
Okay. Thank you. I was just saying Docker key enabler technology for serverless on AWS. So ECS uses it, Fargate uses it. Lambda can run Docker, but it's not highly recommended. Batch uses Docker, and so on. Fargate, you can run your Docker containers without provisioning your infrastructure. So it's a serverless offering. It's different to ECS. ECS, you need to choose and configure your EC2 instance. ECR is your private Docker image repository on AWS. And yeah, batch. We talked about batch, batch jobs, on-demand jobs, maybe at specific time of the day, or the week, or the month. Lightsail, predictable low pricing, simple application. I see this as like framework-based application that you just want to run as you have been running them in the past. Lambda is serverless, it's function as service. With Lambda, really, you have to change a little bit how you think about your business logic and think them as a very simple application. So not just as a server application, but a server application where you have, okay, I have these endpoints, I have these many functions, I have these many integrations. So you just separate them and have that particular function. It's a function that does, maybe it shows the landing page. Maybe that it could be a function. It's a function that runs a background job, maybe to process image. It's a function that connects to the DB to get this type of data and so on. Billing, it's by run, and by run by the time run. So the simpler it is, the less it's going to cost. Lambda does support some heavy application. You can run your entire, like you can convert your Express into a single Lambda. That is possible. However, it's going to disadvantage you on the RAM usage, because if I do a GET request, your whole thing is going to run. So even if you have like 5 endpoints or 20 endpoints or 120 endpoints, they are all going to be available to use in that single Lambda, and it's going to be using a lot of RAM. And the time to run is going to also increase because of the startup time and so on. So better to actually separate that into smaller functions. Language and runtime support has a lot of support for popular languages. Not everything is supported. You can't run a C application in Lambda, and other runtime are not supported, but most popular ones are supported. You can have runtime up to 15 minutes, and also we saw that the RAM can be configured up to 10 GB. So it can run some heavy application like machine learning, but again, not really recommended for like very heavy apps. Like if you go in your 10 GB range of RAM, you probably need to start to think about how to run this in a different way. API gateway, you can use it with your Lambda, and then you have a fully fledged RESTful API app, and you can do things like WebSockets where you can stream both direction. Yeah, so if you need to do your Netflix on Lambda, I'm sure you can run on one. I think that, oh, that's it. So that's it. That's all I had prepared. I didn't think it would be this long, to be honest. Maybe I talk too much. But if you have any question, please ask me. Cold start. Yes, Lambda cold starts are real. Uh, this has multiple factors though. So the size of your application actually determines how long is your cold start. One of the worst cold start is with Java. Java has like a huge cold start. And why Java? Java starts a JVM before it executes the code. So it's not just your application. So you actually have to, so Lambda starts and then starts your JVM and then loads your application before it executes it. So I would say never actually to do Java application in Lambda. Like to do it, it's really kind of like, well, this is what we are using, but I don't think that's very suitable. Same with C sharp, probably not suitable either because you have to start uh, your runtime for C sharp. But things like Node.js, Python, their runtime are fairly fast. Go is very, very fast, and Rust is very fast. So I think I think your code starts really also comes back down to like what language do you choose to use, and when you're choosing languages like Java, you probably don't have you are going to have like your code start penalty. However, that being said, it only happens once in it happens once, let's say in a window of there's many factors, but if you can run your app for at least 15 minutes, you should expect, and you have the code start whenever you have another instance of Lambda. So what you should expect, like when if you have like let's say not too many requests, you actually have like one code start in 15 minutes. So not too many requests. What does that mean? Let's say your execution time is 5 seconds and you have 5 requests in a minute. You only have one cold start in 15 minutes. And the more like you, if you continue to send your request, your Lambda will never shut down completely. It doesn't charge you when you are not running, but it doesn't shut down your application before the end of the 15 minutes. That may change. That may change. For example, if your application is very, very fast, sub like below 1 second, um, and you only have very few requests per minute or per second, it's going to shut the application down quicker than maybe an application that runs for like 5 minutes, uh, and has the same number of requests per minute. So it really changes. But normally your cold start happens. It's not very often. Like if your application is being used, you have very few cold starts. But if it's not used often, then you start to have the heavy penalty on with cold start. That's why you need to also choose maybe your framework or your language carefully there. Oh, another thing maybe I can add there, like when you are using your apps, like your traditional web apps, and you want to have your backend, Lambda backend, I would again recommend you use things like CloudFront to store, like to cache your application, so you don't have like a lot of delays. So maybe the delays can be reserved to the just the API calls, but like your data calls or your static assets can be cached maybe in CloudFront. So that works as well. All right. That's all I had for today. This was much longer than I actually anticipated. I do hope we still have time for some questions. So over to you, Renee.
All right, all right, all right. Thank you, Olivier. Thank you so much. I guess we had a quite an eventful journey, if I would say. We've been containerized in Docker. we've been triggered in Lambda, and we just finished up with sailing using Lightsail on just putting small applications on that. And it was such an adventurous time and session. So if anyone still has any question before we jump into a quick pop-up quiz, please let us know or raise your hand. We'll just wait maybe like a minute or two for you guys to, digest all of that, maybe drink some water, and then we go on with the Kahoot. Maybe stretch a little, and then we do the Kahoot and wrap up the session. Or maybe we can do the stretch after the Kahoot so that we can still use this mind power or brain power to also test our knowledge that we just gotten from our expert, Olivier. So anyone has a question? Counting one. Okay, I've seen a hand raised. Yes, Kevin?
Hello, am I audible?
Yes, we can hear you.
Okay, thank you so much. First of all, I'd like to thank Renee, yourself, and the host, as well as Olivier, for a very insightful session. So my question was on, yes, you mentioned about a limit of 15 minutes, but then again, also you can optimize further in terms of making the application run a very shorter time. I want to know maybe from Olivier's experience on the role of X-ray tracing on optimizing applications to run at a very shorter time. Maybe Olivier can share more about that.
Yes, thank you. I guess that was was that a recommendation? Was that an additional tip,
Yeah.
or was it a question?
It was a question. I was asking, like, maybe what are the best practices, right? Like leveraging X-ray tracing and all those kind of things to make our applications run at the shortest time possible.
Mhm.
To reduce on cost or something.
Oh, yes. Olivier, yes. Over to you,
Yeah,
Olivier.
yeah, I'll take that. So, Kevin, thank you. Yes, there are actually a lot of facilities in Lambda environment. Yes, one of them is X-ray tracing. So when you do your X-ray tracing, the good thing is you can see multiple execution points in your application. Uh, Everything from your API gateway to the point your Lambda is triggered to things like if you connect to another service to the point when that is triggered, and then you can see what's actually taking long, so you can start to optimize that for your app. So things I have seen, if you have like you are connecting to a database, actually a Lambda, when a Lambda runs, doesn't run from the top all the time. So you actually have like a global space in your Lambda environment that when you have things like connections, instead of reconnecting all the time, you can make a connection before you enter the Lambda handler, and you can use that on multiple invocation. So that reduces time. Similarly, like things that you can prefetch, you can literally prefetch them in that global space for your Lambda. Uh, Maybe there are things in S3 you want to load. Maybe there are other, like I usually say, like any IO based type of stuff, like anything that's going to call through a network, could be S3 database, another service. You can do that in that global context of your Lambda. So that subsequent calls to the same Lambda are going to use already the data loaded there. Another thing you have to look at is Lambda. You can create as many Lambda. Like sometimes your Lambda is slow because you are trying to do too many things in your Lambda. So X-ray will actually show you like what's your red spot in the app. It's going to yeah, it does actually some really good things. I recently used it, and you can see like, oh, this call took 3 milliseconds here, 30 seconds. Connecting to DB was 5 seconds, and so on. So you have full visibility, and you can start to say, okay, maybe I'm doing too many things in one. So you can split your Lambda into other things. Like I want something to handle file reading and processing after this. Maybe the HTTP request is complete. API gateway also imposes a 30 seconds execution time. So if you make your Lambda too big and try to do too many things, your API gateway is going to shut it down for you. So it has like a 30 seconds time limit, and everything on the facing the client has to happen within that 30 seconds. So yeah, you can use X-Ray. CloudWatch generally has good indications. Maybe I'll see if I still have one open there. But you can see like your execution time, even for your Lambda. You can see your memory usage. As I said, when you tweak your memory, your performance actually improves. So that's also something to play with. So you may see like your Lambda is a bit slow, and you give it a bit more RAM, and it's going to be faster. So you actually have to sort of experiment a little bit there. I'll just share very, very quickly my screen. So for those, so your monitoring, we have your standard metrics where you get the number of invocation, the memory, like the errors, duration, parallel execution, concurrent execution, how many Lambdas are running at the same time, and so on. So this can also give you some indicators. How many throttles, how many Lambdas are waiting to be executed. So you can configure your throttling here. Sometimes, like if you can think about it, like your downstream service doesn't always needs to be protected, right? Like there's a limit on how many connection of DB you can have. So you can't have your Lambda running like a 10, hundreds of requests at the same time. Maybe you need to configure that. So you can do your concurrent setting here. So you can control how many of them. So there's a lot of things you can configure here. But what I wanted to say here is just high level performance metrics, your traces. This is what he's saying. Kevin is saying this. So you can see like all the connected. Now you need to enable this. You have to explicitly enable that. I think you enable that somewhere here. Monitoring. Yeah. Tracing, you need to enable that and enhance monitoring. And what you end up seeing is your service map. It's going to show you where the request came from, when was it received in your Lambda, how long it's staying in your Lambda, and if there's a downstream service like a database, it's going to show you when did it go to the database, how long did it stay there. So that can give you more insight in what's happening in your application. And that way you can start to make decisions like breaking up your Lambda into multiple smaller apps, even, or if it's too heavy, then you make it an ECS application where it's more optimized to work that way. So that's all I can add on that question, Kevin.
Yes, thank you, Olivier. Kevin, are you satisfied?
Yes, thank you so much. That was really comprehensive. I really appreciate it.
Great, great, great. Thank you, Olivier. Is there any other questions here in the audience? Welcome, Philbert, pardon. Welcome, Philbert. And I can see new people that we didn't start with, but Jean-Eric and Philbert, we welcome you in our session. So is there any other questions? before we jump into the Kahoot quiz? Yes, Gilbert, you're welcome. So counting 1, counting 2, counting 3. Okay, silence means that there are no questions. Cynthia, if you may help me with sharing your screen with the Kahoot game so that we can kick off. If everyone is ready, if everyone doesn't have any other question, then let's go into putting our knowledge to test. Okay. If you're using a phone or if you're using a computer, just open a new tab on your browser and go to Kahoot, kahoot.it, www.kahoot.it, and the code to join is 194998. 194998. As you join, we'll be seeing you on the dashboard. Adnan, the first one to get there. Thank you, Cynthia, for sharing that in the chat box. Adnan, welcome. Zainab, the lady in the house. Jean-Eric, welcome. Welcome, welcome. We're waiting for you guys to join the Kahoot. Join. And we can see that everyone has gotten on the platform, then we'll be able to launch the game. Hillary and Achilles. Welcome, welcome. Philbert. Okay. James, are you the last one to come? Let me check. Okay, Aristide. I think that's everyone. So yes, we can start now. Thank you. So, ready? Yes. So other compute services. Now, you only have 30 seconds to reply. So what is a software development platform that allows to run our application the same way, regardless where they are run? Is it Dolphin? Is it Shark? Is it Docker? Is it ECS? So put in your answers. You only have a few seconds to go. Okay. You can read the question again to be sure that the answer is correct. But in 3, 2, 1, yes. The answer here, Docker, is the correct one. But I can see that some other people mentioned ECS. So, yes, Kevin, you're sitting out. But the question refers to a software development platform that allows application to run the same way, regardless to where they are run. And they have mentioned that Docker can provide a containerized environment for you to test out your applications in the same way. So Docker here is the right answer. So next. There was a 50-50 answer here. So let's see who's on the leaderboard. Achilles. Right. Next. So please read the questions well. You'd like to launch Docker containers in AWS without worrying about provisioning or managing any infrastructure. So which service would you use? Is it ECS? Is it Fargate? Is it ECR or Lambda? So pay attention on the keywords there. All right. So the right answer here is Fargate. But I can see some people replied ECS and some others said Lambda. So as we learned, Fargate can be like used to launch Docker containers without worrying because it's serverless and you won't be managing the servers behind the service that is given to you. So Fargate can be used to launch Docker containers without you managing the whole servers that is running your containers or supporting the whole system. So yes, next. The scoreboard is currently changing, so let's continue next. Then the next question, the third question, which of the following statements is incorrect regarding the definition of the term serverless? We've been speaking about serverless. So serverless allows you to deploy functions as a service. You don't need to manage servers. There are no servers. Lambda is the serverless pioneer. So what's the right answer? Put in your answers. Time is ticking. Time is ticking. Okay. All right. Yes. Now the majority mentioned that there are no servers. So they were saying which of the following statements is incorrect. And the statement here is that being serverless doesn't mean that there are no servers. There are servers. It's the thing that you cannot see them, you cannot touch them, you cannot point a finger to them. There are servers, but you cannot see them. But serverless allows you to deploy, and all other statements are correct without going through all of them. So next. Yes, the scoreboard, Jean-Eric, is on fire. Okay, let's continue. Now, the fourth question, which of the following statements is not a feature of AWS Lambda? Integration with the whole AWS suite of services, automated and continuous scaling, virtual functions for definition of a minimum and a maximum EC2 instances running. Put in your answers, time is ticking. Time is ticking. Time, yes. So now the statement that is not a feature of AWS Lambda is that AWS Lambda is not a definition of minimum and the maximum EC2 instances running, because as we've seen in previous courses or modules, this is a feature of auto scaling in not an AWS feature or anything. So yes. But Lambda can also provide virtual functions, automated continuous scaling, integration with the whole AWS suite of services. Next. Yes. Okay. Jean-Eric is still on the top. So let's continue. The fifth question. A company needs to run thousands of jobs, but would like to not manage the compute resources. What service can it use? Is it ECS? Is it EC2 instances? Is it EC2 spot instances? Is it batch? Put in your answers, put in your answers. Look out for the keywords in the question. Look out for the keywords. Okay. Yes. So they mentioned a company needs to run thousands of jobs. When it comes to jobs, or thousands of it, then batch rings a bell in our minds. So batch is the right answer. And you won't be managing any compute resources because it's a serverless. And it being a serverless as well, you won't be needing, it being part of the serverless services, it also offers you not to manage the compute resources on its end. So next. Okay, things are changing there. Achilles is now on the top of the game. Next. Which AWS service can launch Docker containers on AWS but requires you to provision and maintain the infrastructure? Is it ECR? Is it ECS? Is it EC2 or Fargate? Put in your answer. All right. The right answer is ECS. ECS, in contrary to Fargate, ECS, you'd need to provision and maintain the infrastructure. Even though you'll be launching your Docker containers, you need also to put more effort in providing and maintaining the whole system behind the services, behind the infrastructure. So yes, next. Okay, next. Achilles on fire. So where should you store your private Docker images so that they can be run by ECS or Fargate? Is it an Elastic Docker registry? Is it an Elastic Docker file registry? Is it an Elastic container registry? Or is it an Elastic private container registry? So what would we use here? Put in your answers. Time is ticking. Okay. So now, yes, I can see the majority got it. So it's only ECR, Elastic Container Registry. Elastic Private Container Registry does not exist, I guess, and the file registry as well. So the right answer here is Elastic Container Registry. Sometimes in these questions, answers will be like made up, but made up for you to think that they're the right answers because it just contain the words of the of what is mentioned in the question. But beware, just let what you've learned guide you into this. Yes, next. Okay, Adnan is coming up, so watch out for him. Next. The eighth question, sorry. Which AWS service can be used by developers to create APIs? Is it ECR? Is it Lambda? Is it API Gateway? Okay. Well, API Gateway is a fully managed serverless service that is also or facilitates developers to create or even publish APIs and at a good scale in contrary to Lambda. So next, API Gateway is the correct answer to this question, not Lambda. Okay, Zainab is coming up. Next. The ninth question is, how do you get charged in AWS Lambda? How do you get charged? Are you getting charged per programming language, inactive time, per call and per duration, per number of functions? So how do you get charged in AWS Lambda? Yes. You get charged per call and per duration, per call and per duration. And remember that at the beginning, you are kind of a millionaire because you have 1 million requests free, and then you also get a duration of did you mention duration before? But I guess we've kind of graphed the 1 million the 1 million requests free of charge at the start. Yes, next. Okay, next, Zainab. So the 10th question, how would you best describe event-driven in AWS Lambda? Is it like it happens on a certain day, it happens on a regular basis, it happens at a certain time, or it happens when needed? Put in your answers. How would you best describe event-driven? What does it actually mean? Okay, yes. So the majority is on happens when needed, and yes, because this means that the functions that you create in Lambda are triggered or are put in motion when there is something that happened that is connected to it. So when that thing happened, then the functions start to run. Not on a regular basis, not on a certain day or a certain time, but after it has been created, triggered, yes. So the function runs when it is needed. Jean-Enrique is back on top, so let's continue and see how things will end. Next. A complete cloud beginner would like to create a simple application with predictable pricing. What service to use? Is it EC2? Is it Lightsail, Lambda, or Easy Start? Great. So now I think we've really grasped the understanding of what Lightsail is. Someone wants to just put a simple application running and with a predictable pricing. So Lightsail is the best option to use on AWS. Yes, next. Now going to the 12th question. Zainab came back. Next. So what is the name of a central repository to store structural and operational metadata for data assets in AWS Glue? Is it Glue Data Table? Is it Glue Data Dictionary? Or is it Glue Data Catalog? All right. Time is ticking. So put in your answers. Okay. Okay. Here, it seems like the answers are even, but Glue Data Table and Glue Data Dictionary especially is a made-up name. And the right answer here is Glue Data Catalog. Glue Data Catalog is the central repository to store structural and operational metadata for data assets stored in the Glue service. So AWS Glue service use the Glue Data Catalog, and that's where you can find the metadata, the data about data of your data assets. So next. Next up, yes. And the next question, the 13th question. Which AWS service is a cloud-based integrated development IDE for writing, running, and debugging code? So is it Lambda? Is it Cloud9? Is it Elastic Beanstalk or Code Pipeline? Code Pipeline. Okay, yes, the right answer here is Cloud9. And as we know that Cloud9 will help you run, write, or debug code even actually on your browser. So Cloud9 here is a cloud-based integrated development, which will help you do all of that even on your browser. So Cloud9 is the right answer here. Next. Okay. Jean-Enrique is back. Back. Next, yes. The 14th question, we only have a few questions remaining. So which AWS service is commonly used in conjunction with CodeStar to automate the building and deployment of code changes? So is it Code Commit, Code Pipeline, Code Build, or Code Deploy? Okay. Put in your answers. Yes. Waiting for 2 people, I guess, to put in the answers. Okay. So now the right answer is AWS Code Pipeline, but I can see that only 1 person chose it. But as a reminder, Code Pipeline is also a fully managed service, yes, but it will help you to I would say to automate your pipelines or release pipelines in a fast and reliable application and infrastructure update. So it usually used with CodeStar to automate the building and deployment of code changes. So whenever you do the changes and you put them out, it allows it to streamline it with CodeStar and to put the latest release out there in terms of the delivery services, if I would say. So yes. Next. Okay. Next question. I was wondering if it is still on top. Which AWS service can be used to store and manage your source code repositories and be integrated with AWS code pipeline? Is it code build? Is it code deploy? Or code commit? Or code artifact? Please do read. Okay, so yes, code commit is the right service to help you store, manage your source code repositories, and it is integrated with code pipeline, of course. Yes, so it provides version control, even for software as well. Yes. Next up. Please next. And the 16th question, you want to create a decentralized blockchain on AWS. Which AWS service would you use? Is it DocumentDB, QLDB, manage the blockchain, or QuickSight? QuickSight. Manage blockchain, QLDB, DocumentDB. Yes, managed blockchain, as it has been selected by the majority, is a fully managed services that would help you manage scalable, decentralized blockchains on AWS. Yes, next. Zainab came up again. Yes, next. The lady in the house. Which AWS database is a data warehouse? Is it Redshift? Is it Elastic Cache? Is it DynamoDB or RDS? Yes, Redshift. It's in red as well. And Redshift is a fully managed service as well, which is a petabyte, I guess. Petabyte scale, yes. Petabyte data warehouse service in AWS. Yes, next. So those kind of terms, petabyte, exabyte, you'll find them really useful, but because sometimes you might get a question even describing the chunks of data you would be needing or maybe migrating or using. So those kind of terms will actually really help you. Sometimes they might provide such specific details which you'll need to also take into consideration. So yes, next. Which of the following is an exabyte scale data moving service in or out AWS? Is it Snowcone, Snowball Edge, or Snowmobile? As I was just mentioning, now they have put in the number of data you need. Yes. So for exabyte scale data, Snowmobile is the one to help you do that, because Snowcone and Snowball Edge, they're kind of lower. They have other amounts of data they can move, but when it comes to exabytes, a Snowmobile is the best in and out. Next, please. Okay. Next question. Which relational database is a proprietary technology from AWS and is cloud optimized? Is it DynamoDB? Is it Athena? Is it Oracle or Aurora? Aurora, Athena, Oracle, DynamoDB. A proprietary technology from AWS. Which relational database, of course. So yes, Aurora is also, it being a proprietary technology, it can also, it is also, yes, compatible with MySQL and PostgreSQL, and also a relational database But on the other hand, Athena is mostly used on S3. So when Athena comes into play, it is when they're telling you maybe they want to extract data from an S3 bucket and they want to analyze it. So Athena will be like an SQL service because it has really a smooth and interactive SQL queries that will help you extract vast amounts of data from S3 for it to be analyzed somewhere else. So Athena, when you see maybe S3 or queries or anything, that's when Athena will be coming in. But Oracle, you already know about it, and DynamoDB. So next. Yes, Zainab. So we're getting to the last question, and if Zainab is still on the top, then a team deployed in a location with low internet connection would like to move 5 TBs of data to the cloud. So which service do you think they will need? Is it storage gateway? Is it Snowball Edge? Is it Snowcone or Ops Hub? So storage gateway, Snowcone, Snowball Edge, or Ops Hub? Yes, Snowcone. I think so the question asked a question deployed, not a question, a team deployed, sorry, in a location with low internet connection would like to move 5 TB of data, 5 TB of data to the cloud. And Snowcone, I guess Snowcone is can provide, I think it can provide over like 8 TB. So if they mention here 5 TB, so there is, as you know, in the Snow family, there is a Snowcone, there's a Snow Edge, a Snowball Edge, sorry, and there is the Snowmobile. So the Snowcone can provide like up to 8 TB, and then a Snowball Edge can provide around 10 petabytes. And then for for Snowmobile, sorry, it can provide over exabytes. I think it's 1,000 petabytes. So Snowcone is the smaller, and then there comes the big brother, Snowball Edge, and then there comes the big father, if I would say, the Snowball Mobile, the Snowmobile. Well, this Snow family is quite a mouthful, and I'm having a hard time pronouncing them. But Snowcone, Snowball Edge, and Snowmobile. Yes, I guess that's the end of our Kahoots. So we're gonna see who is on the podium, the leaderboard. Now the third person, Hillary. The second person, Zainab. And the first on Spotlight is Jean-Eric. So kudos to Jean-Eric. And the runner-ups, the fourth Ashil and fifth Aidnan. Really kudos to you guys to have participated in all of this. And I will still encourage you to keep doing more tests to understand better how the questions are asked and how even the answers given to your questions or the multiple answers are given. You'll need to really read and rely only on what you know, not only by guessing, because they might make up things just to put you off course. But please just keep reminding yourself what you know and go in there with only what you know. So if you ever see something that is a red flag in a question, just know to choose the best answer, because some of the answers could be correct, but the best answer is the right one, is the suitable one they need. So yes, without taking much of your time, if you still have any questions but didn't get any chance to ask it, please do ask it before our expert, Olivier Nsabimana, our guest speaker today, leaves the session. But if not, maybe the following session will be put out before the week ends. before, not before this weekend, but before next week, because of course we'll be having a next session Saturday. So watch out on our platform, and if you would like to get to know more information, join our WhatsApp group. I've sent the link in our chat box. If maybe you need it again, I can resend it. You can also follow us on LinkedIn. We also have a LinkedIn account and profile, as well as on Twitter. If you want to keep an eye on our program and different activities, please do follow us on LinkedIn and Twitter as well. And keep an eye on the WhatsApp group. If any interesting programs arrive, we'll let you know. We'll put you guys in the loop. And yeah, keep practicing, keep reading, because all of this, well, at the end of the day, you'll sit on a chair in front of a screen and it will be only you facing the exam, the whole practitioner thing. So keep doing the thing, and let me just hand over the microphone to Cynthia if she has well, a thing or two to tell us maybe about the challenges. A last reminder.
Yes. Can you hear me?
Yes, we can.
Okay. Thank you so much, Olivier and Renee. This was really insightful. Learned a lot and had fun listening to both of you guys. So thank you so much. I think what I can add on here is for the challenges, and at the same time announcing the winner. The winner for the last week's challenge is Jean-Eric Tuyishimire. So yeah, congratulations, and I will share with you the credentials. I mean the information about your voucher. And we have another challenge, and we still have one more voucher. So whoever is going to finish this challenge also will win a $25 voucher. It's important that when you're starting the challenge, you enter the code that was shared in the challenge description, so that we're able to track your progress and to make sure you finished everything. And yeah, I think that's it for this challenge. You have to first finish the first challenge for you to access the second challenge. We're still using the cloud quest. I don't know if anyone has any questions on the challenge, or otherwise we can just end. Thank you.
Okay, kudos to Jean-Eric. He also won today's Kahoot game, so more wins up your sleeve. And I guess you continue. I encourage everyone to just keep trying, keep trying. Things might seem like really they are quite impossible, or maybe they're difficult to learn. You might find that AWS has a couple of services that will be amazed to hear that you haven't even heard of, or maybe seems like a challenge to you. But that's how things are. Everything worth learning is worth also putting the effort in learning it. So kudos to you guys. Keep learning. This is where we end. This is the end of the sail in Lightsail of the Docker or the shipment that we've been into. Thank you so much, and see you next Saturday. Please show us some love on our social media platforms. Go and go and follow our page, and we'll be here for you guys. Thank you so much. Maybe everyone can unmute and say one last goodbye. So let me first go. Bye, guys. Goodbye.
Bye.
Bye.
Nice.
Thank
Bye.
you.
Bye. Bye.
Bye. Please make sure that you leave at least saying goodbye. So do say goodbye for us.
Okay, bye everyone.